Okay, this video covers numbers 1 and 2, the proofs on the Chapter 3 test version 2. So we'll start with this shorter proof here. We were told that T was equal to, angle T was equal to angle R. So I'll mark that on my diagram. And that's given information. So line 1 is pretty straightforward to fill in. But then next we're told that UST, I'll use 2 markers for that, is congruent to QSR. Now why would we know that? Well, we're familiar with that cross of segments or lines or rays. When we cross them, we create pairs of congruent angles that are across from one another, this here. And we call pairs of angles like that vertical angles. And we know at this point that they are congruent from the previous chapter. Okay, and then finally I'm supposed to prove that angle U is congruent to angle Q. Now how would I know that? Well, what I'm going to do is highlight the triangles that we have showing here. We have this triangle and this yellow triangle. And I know that this angle is congruent to that angle, and this angle is congruent to this angle. I know that triangles must sum to 180 degrees. So if these two are set values, there's going to be the same amount left for angle U as there is in angle Q. So there was a corollary to the triangle sum theorem which said that if two angles of two triangles were congruent, then the third angles were also congruent. So that one gets done pretty quickly if you realize that corollary. Number 2 is a little bit longer, so let's get started on that one. Let's see. Our given information is angle 1 is congruent to angle 3. And that Kn bisects JKM. I'm going to hold off on writing anything in yet because I'm not sure which given I should put in. I see there's a given here, and then obviously there's going to be a given here. What goes where? Well, does bisecting an angle ever prove parallel lines? No, that's not on our list. Our list had a bunch of angle relationships that proved parallel lines, like alternate interior, same side interior, corresponding, etc. So hopefully we can recognize that angle 1 and angle 3 are one of those angle relationships. The transversal is going to be considered JL, and these two lines here, if these corresponding angles are congruent, must be parallel. So it looks like the best thing to put in the first given is that angle 1 is congruent to angle 3. And then the reason that these two lines are going to be parallel is that if corresponding angles are congruent, then lines are parallel. Alright, so now we're going to move on to this information. Angle 2 is congruent to angle 4. Well, I didn't really know that. Let's change color here. So 2 is congruent to 4. Now, why would I know that? Well, we were just talking about parallel lines, and you think about these two parallel lines that I've highlighted in red, and you think about KM now as our transversal. You notice that 2 and 4 are on different sides of the transversal, but they are inside, sorry about that, they are inside the parallel line. So we call those kinds of angles alternate interior angles. Since we know that the lines are parallel, we can now say that alternate interior angles are congruent due to parallel lines. Next, we have got a given in our partial proof here, so I'm going to write in the other given information. Kn bisects angle JKM. Now let's go to JKM. JKM. JKM is composed of angle 1 and angle 2. And we know that bisect means cut in half, so we must know that angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2. Why do we know that? Well, there were two things that came up with a bisect. There was either definition of angle bisector, or there was angle bisector theorem. We only use the theorem if we see a computation involving the term 1/2. So it must be definition of angle bisector. All right, now I know what the last line is supposed to be. It's supposed to be angle 3 is congruent to angle 4, but how would I know that? Well, let's look back. I just proved that 1 and 2 were the same. Previously, we knew that 1 and 3 were the same, so let's change angle 3 to green. We also know that 2 and 4 are the same, so it turns out that 1, 2, 3, 4 are all congruent. So it's perfectly fine to say that 3 and 4 are congruent, and we would use substitution kind of twice, or you can say that that's a transitive property. That's your reason. And that completes this section.